when rectangles and parallelograms have equal area. Let's look at how a rectangle and parallelogram can have the same area. In this diagram, the parallelogram and rectangle share a vertex, D. One vertex of the rectangle, E, is on a side of the parallelogram, and one vertex of the parallelogram, C, is on a side of the rectangle. That is enough information to guarantee that the rectangle and parallelogram have equal area. Let me repeat. That is enough information to guarantee that the rectangle and parallelogram have equal area. That's what you need to know for the GRE. In this video, we'll take a closer look at 2 ways to know this works. First, I will construct segment EQ, which is perpendicular to segment DC. This segment is the height of the parallelogram, so EQ times the length of DC is the area of the parallelogram. Look at triangle DGC and triangle EQD. These 2 triangles are similar. Why? Well, first of all, angle QDC and angle EDQ are complementary. They both add up to the 90-degree angle of EDG. Also, the angles QDG and QCD are complementary because they are the acute angles of a right triangle. Since angles EDQ and QCG are both complementary to the same triangle, QDG, they are congruent. Therefore, angle EDQ equals angle QCG. Since we know that the angle EDQ is congruent to the angle QCG, and we know that both angles EQD and DGC are right angles, therefore we can say that 2 angles in the triangle DGC are congruent to 2 angles in the triangle EQD. With the AA similarity theorem, angle-angle similarity theorem, we know that triangles DGC and EQD must be similar triangles. Similar triangles have proportional sides. In particular, we can set up the following proportion between the triangles, which says segment ED is to segment EQ as segment DC is to segment DG. Using algebra, we can cross-multiply to get 2 equal products. Or, as the equation says, segment ED times segment DG equals segment EQ times segment DC. And would you look at that? We already said segment EQ times DC is the area of the parallelogram. And as you know, segment ED times segment DG is the area of the triangle. Therefore, these 2 areas are equal. That's one way to prove these areas are equal. But just for fun, let's look at another way, one which may be more appealing for visual thinkers. We'll call it the sliding method. Let's think of a parallelogram. Now, imagine extending one pair of sides in the parallelogram like railroad rails. If we slide either side along its rail, the shape of the parallelogram will change, but the area will stay the same. Because the base, the length of the rail, doesn't change. But neither does the height, which is the distance between the parallel lines. So both our original parallelogram and the new one must have exactly the same area. That's a huge geometry idea. Now, think about our diagram with some rails added. Now, when we slide AB upward, so that A coincides with E, that will make both AD and BC perfectly vertical. Now, if we slide BC down so it exactly coincides with FG, then the parallelogram will exactly coincide with the rectangle, which means they must have identical areas. This sliding method can be a very handy shortcut with parallelogram areas. Magoosh is test prep that you can do on your phone or computer, and we guarantee it works or your money back.